Okay, so here we go. This is just a basic introductory video, the first one, to using a modular synthesizer. And first we're just going to take a look at the modular synth system that we've got here. These are the different modules. We've got two racks, one on the bottom that's horizontal and one that's vertical, and they contain a bunch of modules. Each module does a different thing. They're made from different manufacturers. And to start off with, we're going to look at a couple modules. We're going to look at the Rene, which is named after René Descartes, and it's made by a company called Make Noise. They make some great modules. This is a sequencer. We're also going to look at the Polivoks filter. That's right here. This is based on a Russian design filter. Very cool, very interesting, from the Soviet era. We're also going to look at another company that has some Russian influence. That's Xaoc Designs is the company, and this is a module they make called the Batumi. It's 4 low-frequency oscillators. A very, very cool module. A lot of people really like this module. We're going to look at that. And we're just going to look at those 3 modules. We need a sound source, and we're going to use the Intellijel Dixie 2 Plus, which is my favorite oscillator. It's really small, which is great, but it sounds wonderful, very versatile. You can use it as a sound source oscillator, or you can use it as a low-frequency oscillator. But we're going to use the Batumi for our LFO, for our low-frequency oscillator, and we're going to use the Dixie as our VCO, voltage-controlled oscillator, which means an oscillator in audible range, meaning that we can hear it. It's going to make some sound. So what we're going to need to do first is we're going to patch the Dixie's output. Now, if you look down here, so the Dixie is a VCO, voltage-controlled oscillator, which means it's an oscillator that makes sound. It oscillates and makes sound waves. It can make different types of sound waves. And it's voltage controlled, meaning it can be controlled, it can be modulated by controlled voltages, which you plug into it. So it has inputs and outputs. So here, Intellijel has made it easy for us. The top 6 are the inputs. You can see you have 2 frequency modulations. Those are FM 1 and 2. Pulse width modulation, which is PWM. You've got 1 volt per octave, which means that's the pitch coming in. You've got a sync and a flip input. And then you've got, which we're not going to get into, mainly because I don't understand what they do. And we've got 6 outputs, which are different types of waves. So we've got a regular sine wave. We've got a triangle. We've got something that I don't know what it is. We've got a saw wave. We've got a pulse wave. And we've got a sub-octave output. And at the top, we've got a little slider that's going to let us change octaves easily. And we've got little trim pots for the amount of frequency modulation and pulse width modulation that we might want to do. So we're going to go with the triangle output. That's a pretty simple output. We could go directly from that into our output. And if we did that, it would sound like this. I'm going to send it through Clouds, but Clouds is off. So this is basically just going straight to our output. And there you see, it's just making a constant sound. And if we move this is the tuning knob. It's going to go up and going to go down. It's making a constant sound. If we move the octave button, it's going to go up an octave, another octave, go all the way down. So let's leave it around there in a middle point. Okay, so that's what the oscillator sounds like by itself, not that interesting. So what we're going to do is we're going to want to feed that oscillator different pitches, and it's got this nice 1 volt per octave input, which is right there. So we're going to plug that in, and we're going to plug that coming from the QCV output of the Rene, and that stands for quantized CV. So quantized CV means it's going to send a control voltage pitch out. That's the CV, control voltage. And quantized means it's going to be in a particular scale that we set. And on the Renee, if we go to this advances to different menus. So now we're in the Q menu. It shows the scale that we want. And it might be hard to read, but what we have here is we have different scale notes here that say C, C sharp, D, D sharp, E, and so on and so forth. So what we have here is a major scale that I have put in, C, D, E, F, G, A, and B. So it's going to send out an output in that scale. These little trim pots here are going to determine the pitch. So I'm turning them all down, so they're all down at the lowest pitch right now. And it's not playing any different notes because there's nothing advancing the sequencer, right? So it's just stuck on one note. So what we need is an output that's going to advance the sequencer. Now the Batumi is 4 low-frequency oscillators. And each oscillator, each LFO, has different outputs. So the top one is a sine output. The next one says saw or assignable, meaning it could be something else. And the bottom one is square. So these are different waveforms. A square waveform is a waveform that's either on or off. So that'll actually work pretty well to send triggers, because it's just going to send an on or off signal. And we can use that to advance the Renee sequencer. So up here, if you look at those lights that are blinking, a friend of mine asked me, are the lights just decorative? But they're not. So see, if I turn this up, it blinks faster. That's showing it's going faster rate. And if I pull it down here, it's going slower. So this slider is determining the rate of the oscillator. And if I set it to square, it's going to send out a pulse that's at that rate that you see it blinking at. So that's a pretty slow. See, it's coming on and off. So I'm going to patch coming out from that square, and I'm going to bring it into the X clock. The Renee has 2 clocks. One that advances on the x-axis, that's this way. It's going to advance it from here to here to here to here. And the other that advances it on the y-axis, which is up. So I'm going to put it in here. And now what we notice is it's actually advancing it, but since the pitches are all set to the same, you can't really hear it. I'm going to turn these up a bit. And now you're hearing it advancing. It's advancing pretty slowly. So let's come back here to the Batumi. Let's turn that up a bit. Okay, so now you hear it. It's the Batumi is sending out a low frequency oscillator in the form of it's sending out a square wave at that tempo, and it is advancing the Renee along the sequence. And you can set up the Renee in different ways. It's in so it's advancing that, and if we change the trim pots here, we basically change the notes that it's playing in each when it reaches that position. Okay, we can even come up here and speed that up slightly more. Okay, so now we've got a little melody going, right? So the Batumi LFO is sending out these signals in the form of square waves, which are either on and off. When it's on, it's advancing the Renee. The Renee is sending a quantized CV output into the Dixie, which is pitch information, and the Dixie's triangle wave is sending the sound out. So now to make things a little more interesting, we can take the Dixie's output and we can run it through the Polivoks filter, which is up here. So we're going to unplug the Dixie's sound output. We're going to put it into the Polivoks' input. We're going to take that Polivoks output I'm going to send that back to our main output. Okay, and we're hearing that melody again. Now the Polivoks is a filter. It's kind of like an EQ device. And right here, it says Chastota Sreza in Russian. And if we turn this, we're getting the filter effect right there. So there's that Soviet filtering going on. Now, what we can do is we can have, we don't want to just have to wiggle that and turn that ourselves. I mean, we could. We can automate that. So let's say we want to turn that knob but not do it ourselves. We'll use the Batumi to do that for us. So we'll go down here. This time we'll use one of the sine wave outputs. So I take the second LFO of the Batumi. It's got 4 channels. And we take that, plug that into where it says CV1, that's a controlled voltage. That's going to control that filter cutoff there for us, so we don't have to turn it ourselves. This knob here shows the amount of the control voltage that we want. So you see it's in the middle right now. It's not plus or minus anything, so we're not hearing an effect. If we turn this up, this is plus now, so it's increasing the filter cutoff. And we can change the rate of the Batumi LFO. So you see this is the second one we're using. As we turn that up, the filter cutoff is changing at that rate now. And again, this little dial here, this little trim pot, sets the amount of modulation. If we turn it too high, then we notice that the modulation actually cuts out the filter entirely, which we might not want. Now we've got another CV input, CV2, which is going to control the resonance of the filter. And this is what the resonance sounds like. So we want that controlled also, so we can take another output from the Batumi, say the 3rd channel, feed that into the resonance. Make that a little faster. That's if it's really fast. Slow that down a little bit so that we can still hear it, so it doesn't cut out entirely. That's kind of turning the filter off quite a lot, so we might not want that. We could, of course, use the same LFO as we are using to advance the sequencer. And what that would do is it would keep the resonance in line with the actual melody. So if we have it go out of the same one. So now you hear that resonance is being controlled at the same tempo as the main melody, because they're both coming out of the same LFO, just different outputs. You can have each LFO send out all 3 outputs at the same time. So we could use the saw wave output too. We could also, instead of controlling the resonance there, we could use that output to do some frequency modulation on the Dixie. So for example, take that output from the Batumi. So lots of patching possibilities there. Another interesting thing is that we can patch the Batumi into itself. So for example, in addition to its outputs and using the sliders, the Batumi has two inputs on the top, one for frequency and one for reset or sync. So you can modulate the frequency. So you see that first one, it's advancing the sequencer, the Renee, at that speed right now, right? If we push it down, it's going to slow down. If we're going to push it up. But we can change that tempo by, say, having a slower sine wave, like the Batumi's third channel, send that out and patch it into the frequency input of channel 1. So now this LFO is changing the speed of this LFO. So you see it going really, really fast and then going really, really slowly. So that's just some basics of the Batumi, the Polivoks filter, and the Renee, and using our Dixie VCO as the sound source. That's a very simple patch.